to today's session of Scene Layers and Developers. My name is Voxelaire and I'm the product owner of the Scene Layers team. We are a functional team covering all aspects of scene layers from specification to creation to client consumption, such as in Arcgis Pro. I'm working in software development for over 10 years and I'm the product owner of the Scene Layers team for about 5 years. Our team knows how important it is to our customers and your customers to enable developers to build applications. We are adding more staff to our team to work on Arcgis Pro and Esri SDK, Esri specification, and tooling. With me here is Richard Vargas. Richard is working as a product engineer on the Scene Layers team and is focused primarily on Esri specification and Esri SDK. Before we dive into the details, I would like to give you some background on why you would want to use a scene layer in the first place. Scene layers allow you to create, manage, visualize, and analyze 3D layers with large volumes of content, achieving high performance, visual quality, and analytical accuracy across the Arcgis platform. You can create 3D datasets for your workflow's needs. 3D datasets can be combined, enhanced with data attributes, perform well with multiple levels of details, and have realistic materials. Scene layers are items that can be managed within Arcgis and participate in standard enterprise workflows to write and update GIS content. All Arcgis clients or other clients supporting scene layers can visualize 3D layer types. You can analyze 3D layers using geoprocessing tools, geoprocessing with interactive selected subsets of the data as input, general interactive tools, or specific ones for 3D layers. Partners and data providers can create 3D layers as scene layers with tools provided by Esri or implementing the Esri specification in their own data pipeline. The scene layers lifecycle is defined by 4 areas. You can author scene layers in many Arcgis clients or use third-party vendors. You can publish content to share across the Arcgis platform. In Arcgis Pro, the authoring and publishing steps are combined when sharing a web scene or a web scene layer. You can also upload SLPKs, or for very large scene layers, you can extract an SLPK and use it in a file system or cloud storage. You can consume it in clients such as Arcgis Pro, Runtime, Earth, or Scene Viewer. You can maintain scene layers by replacing the service or by editing the scene layer with associated feature layer in Arcgis Pro and rebuilding the cache for the scene layer in Arcgis Enterprise or Arcgis Online. Let's look at the different areas in more detail. Currently, you can create a scene layer from the following input types. For point clouds, you can share a last dataset layer from Arcgis Pro. With this, all symbology and properties you have defined will be honored. Or you can directly create an SLPK from last Z, or ZLAS input. Point clouds support 32-bit, which allows you to create very large point cloud scene layers. Integrated meshes are often created by third-party vendors. But you can also use OSGB data in the Create Mesh Scene Layer Package tool or use Drone to Map to create integrated meshes. You can create a scene layer from Multipatch as a 3D object scene layer or point feature classes as point scene layers. Depending on the way you share them as scene layers, you can create a scene layer with an associated feature layer that gives you the ability to edit or search on the scene viewer. The latest scene layer type we introduced was the building scene layer created from a building layer. Building scene layers allows you to visualize 3D building information in ArcGIS. You can capture all details of a building, starting from a pencil on a desk to having multiple buildings on a campus. You can alter scene layers in Arcgis Pro after you have prepared your scene or a layer that you would like to share. You have 4 options to publish. Within the web scene layer, you can share all layers within the web scene. A scene is always shared by value. That means the data are copied to Arcgis Enterprise or Arcgis Online. For feature-based scene layers, such as 3D objects, point scene layers, or building scene layers, an associated feature layer is created. The coordinate system of the scene layer is identical with the coordinate system of the published web scene. You can change the properties for the scene layer, for example, to make it editable. If one of your layers has a local SLPK as data source, this data source will be published for the web scene layer as well. You can share an individual layer as a web scene layer. Here you have the option to share by value or by reference. If you share by reference, your data remain in your enterprise geodatabase or as read-only in your file geodatabase. Also in this case, you can define the editability for associated feature layers and maintain the scene layer. The coordinate system is the same as the scene you're authoring from. When adding the layer to an existing web scene, the coordinate system needs to match. In Arcgis Pro, you can always reproject the data, but that comes with a price. The layer may draw slower because of the reprojection. In case you plan to edit the data, we always recommend to do this in the same coordinate system. You can create SLPKs. We have specific tools for every scene layer type. We improved the way you can work with scene layers in geoprocessing. Now you can create scene layers and SLPKs using the model builder, for example. After you created an SLPK, you can upload and publish or use it directly as data source in Arcgis Pro. In this case, the scene layer is cached on the client and the feature-based scene layer, such as points and 3D objects, would not have an associated feature layer. You can use Esri as tooling to extract very large SLPKs directly to a file storage or cloud storage. After extracting, you can create a service using Python. This saves you a significant publishing time. Richard will show you an example in a demo. As I already mentioned, our team is working on Esri as well as on the Pro implementation of the client. Therefore, I'd like to show you examples of how scene layers are consumed in Arcgis Pro. I'm sure you have seen the consumption in other clients like JavaScript, API, and runtime already. With point clouds, you can visualize LiDAR data with billions of points. This layer type is supported in all Arcgis clients. Already in Arcgis Pro 2.3 and Enterprise 10.6, we optimized the layer for dense interior and exterior point clouds. When using a point cloud scene layer, you can make changes to its appearance, such as changing symbology or set a filter. An integrated mesh scene layer allows you to capture all 3D information in one layer. In Arcgis Pro 2.6 and Arcgis Online, the integrated mesh scene layer supersedes the ground and the base map. That means that, for example, a line, polygon, or point feature layer that is draped on the ground is also shown draped on the integrated mesh. Usually, you want to show integrated mesh together with other GIS data. For example, you want to place a new building in an existing reality capture of the mesh. You can do so by modifying the mesh. You can do it by editing the modification in Arcgis Pro, or use the JavaScript API. A building scene layer can be consumed in Arcgis Pro and the Scene Viewer. Building layers are structured into disciplines such as architectural, structural, or piping, for example, or category layers such as walls, windows, and pipes. With a building scene layer, you can quickly toggle on and off category layers, but also apply filters to find assets within your building quickly across the whole building. The building scene layer is a feature-based scene layer, allowing you to edit and search the building scene layer on the web as well as in Arcgis Pro. Point scene layers you can consume in all Arcgis clients. You can change the symbology. If shared as a scene layer with associated feature layer, you can also edit the points. Point scene layers are used mainly if you want to visualize millions of points, such as trees, for example, that you can see here. A 3D object scene layer allows you to visualize millions of 3D objects in combination with an associated feature layer. You can also work with them the same way as you work with feature layers. You can consume a scene layer in Arcgis Pro, Runtime, or JavaScript API. You can change the appearance of a layer such as symbology, you can hide features, you can query, and many things more. Currently, you can maintain feature-based scene layers if they have an associated feature layer, and editing is enabled. You can share by reference, where you keep the associated feature layer in your enterprise geodatabase, or by value. In this case, a copy of the associated feature layer is made into your data store. You need to set the editing option on the associated feature layer and make sure that the option to always set Z to 0 is disabled. This is really all you have to do. Now users with editing rights can edit the scene layer in Arcgis Pro. For us, it was very important that all editing workflows you already have for editing feature layers remain the same for editing scene layers. As a user, you don't see a difference if you edit a scene layer or a feature layer. You can also use the scene layer for input as geoprocessing if you have an associated feature layer. The only difference is that any user consuming the scene layer without editing rights will not be able to see the changes until you have recreated the scene layer cache as a full or a partial update. For example, if you have a scene layer representing the outer shell of a building in your city, you can make updates to the scene layer and rebuild the cache. The moment you rebuild the cache, your changes are visible to all of your users. After this overview, Richard will talk about Esri specification and the SDK.
Thanks, Yvonne. Hello, everyone. My name again is Richard Vargas, and I will be presenting some wonderful tools for development related to i3s, otherwise known as indexed 3D scene layers. i3s is a specification for streaming and distributing geospatial 3D content. i3s is also a community standard, meaning it is a widely adopted format. This is not only an effort by Esri, but partners, customers, and others in the industry. A few adopters, such as Inframes, Vricon, Nearmap, Pix4D, Bentley and Context Capture Partners, and Safe's Autodesk currently use i3s. On this slide, there is a link to the i3s GitHub, which contains specification organized by profile type. These profiles include 3D object, integrated mesh, point cloud, and building scene layer. Along with this specification, this GitHub also contains a scene layer upgrading tool. This tool can upgrade your SLPKs to the latest version validate your current i3s output schema, and extract to file and cloud storage. This tool has no dependencies on ArcGIS and has an option for running commands with multiple threads for faster computation. An example usage of this tooling is extracting an archived SLPK to a file storage ESLPK format for server consumption. The i3s Converter tool is a command line tool which performs a handful of tasks. I am interested in extracting my San Francisco SLPK to file storage to later put on my server. This SLPK is rather small, so I don't use the multi-threading option here. The output returns the first 10 lines of the log file if it ran successfully and other location information. In my File Explorer, I can see that the SLPK was extracted to the file system, and I can open and browse its contents. This next section I am particularly excited about, which is the i3s SDK. This slide contains a GitHub link separate from the i3s specification, which contains the i3s SDK repository. The i3s SDK allows developers to write i3s by abstracting the lower level work. Reading of i3s content will be coming soon. We understand the need for data integrity, especially with sensitive data, and have thus made the SDK open source. The SDK is supported on Windows and Linux. It is written in native C++ and creates the newest version of i3s, which is version 1.7. The repo also includes an example application which creates an integrated mesh scene layer from sample data. This diagram represents the parameters needed for writing integrated mesh using the SDK. On the left side, we have the properties of the layer, which includes name, SLPK path, description, layer type, coordinate system, and normal reference frame. The middle column, starting from the bottom, we have the information which defines the layer, such as vertices, texture coordinates, and texture, which is used to create the mesh, then the nodes. These two sets of information are brought together at the layer writer, where it creates the layer and writes it to disk. And now I would like to actually show you this Create Integrated Mesh demo application in action. The demo application, roster to SLPK, takes an elevation image, texture image, output file name, the X and Y resolution of the images in meters per pixel, and the elevation unit in meters. Here, we have the input images, an output name, 10 meters per pixel as the longitude and latitude, and 0.1 meters for the elevation. Now we have a small Python script which uses the ArcGIS Python module to publish the newly created integrated mesh layer. This script publishes the SLPK to an ArcGIS enterprise portal. Going into the enterprise portal, we can now open the layer in Scene Viewer. Once the layer is open, we can now visualize the integrated mesh layer. Now we are ready to share this layer with our colleagues, friends, and anyone who may be interested. I now want to take a second to mention another available SDK for .NET, the Arcgis Pro SDK. With the Arcgis Pro SDK, you can extend ArcGIS Pro. For the Scene Layers team, we give the ability to create scene layers from a generic layer and the iScene service layer info, which can be thought of as an interface to what a particular layer can do. This SDK can be downloaded from my.esri.com or from Visual Studio Marketplace. So what's next for i3s? Version 1.8 will be releasing this year, with a new property for all layers, full extent, which will allow clients to zoom to the layer. A new compression format, Basis, will also be supported in the newest version. The i3s SDK will continue to be developed as well, and we will be soon releasing another sample program, Integrated Mesh, from OBJ. Thank you for your time, and have a wonderful day.
Hello and good afternoon for people in Europe. And like myself, my name is Yvonne Zela. You heard the presentation. With me here is Richard Vargas.
Hello,
we are both working for the Scene Layers team, and we hope we could give you a good overview of the i3s specification and the different SDKs that we are currently working on. We now have time to answer additional questions or go into more details of things that you have heard and you might be interested in. We got a couple of questions in this Slido tool for while the presentation was running. And one of the questions was, what are the benefits of Basis versus the current texture formats?
Yeah, and I'll go ahead and answer that. So the benefits of Basis are actually, it's an interchangeable format compared to the other texture formats. So when you're transcoding the Basis to whatever format your GPU requires, Basis is really good at that transcoding portion. So if you're on mobile or the client is a mobile client or a desktop client, you can easily transcode the texture for consumption on that client. And the Basis compression is actually extremely efficient compared to other compression techniques.
One more question that we also have for Basis is what will be the release, when will this be released in clients?
Yeah, so we plan to include Basis in the 1.8 specification, which should be coming out later this month. And for Esri clients, currently the only one that will be producing Basis will be the i3s converter. And for consumption of Basis, we will have our JavaScript API and the web scene viewer, with more clients to be coming out in the future.
Just now, a question came in, are scene layers going to be available for consumption, other SDKs than JavaScript? Scene layers are available, of course, in Arcgis Pro, as you have seen it in the presentation from Richard. But scene layers are also used integrated mesh and 3D objects with Unity and Unreal SDK from Runtime. I don't know if you had a chance to look into the presentations from Adrien, who might have mentioned that. So scene layers are really the way to share 3D content across the Arcgis platform, not just from users using the client itself, but also for developers. One thing that I have not mentioned yet, but what we would really like to see is we have this poll open for the i3s SDK, mainly because this is something that we are fairly newly working on, and we are at this point not quite sure what users really expect from this open source version of the SDK, or if they usually would prefer to keep working with other SDKs like in runtime or the JavaScript API. For example, we have heard from people that they would like to have a little sandbox where they can try out scene layers for reading, for example, so that the traversal of the tree can really be exercised in small examples. On the other hand, we also heard that the data creation, of course, is quite important for people, meaning that, for example, the OBJ tool that Richard has mentioned, and we really hope to show you today just live, but unfortunately it didn't work out, to create integrated mesh scene layers, for example, but maybe also other content like really large point scene layers, for example. I'm seeing now more activities in the poll, so thank you very much for that. One question that we see here, what would be the advised approach to publish 3D building layers, including one-to-many related attribute informations? A building layer can have a relationship class. And how you would publish this is you would first create or you would use the BIM file to geodatabase tool and put it into your enterprise geodatabase or file geodatabase, depending on your GIS system. You would then relate the layer that you want to, for example, for the rooms that you have a relationship class there, and then you would publish it. The relationship class would be cached as well, and would then also move into when, for example, when you consume it in Arcgis Pro or in the scene viewer, you could see the related table.
Looks like we have another question here. It says, would it be possible in the future for integrated meshes to be created in ways other than 3D party vendors? Or some of the features from integrated meshes being added to multi-patch features? Well, the i3s SDK, actually, we showed the integrated mesh being created from the elevation and texture. So you can actually develop your own program or use ours that we have as the example on the repo to create integrated mesh. Or if you're talking about actual data creation, Yvonne might be able to speak more to that.
Which part of the data creation do you mean?
Like getting the actual elevation and texture images.
I'm sorry, I'm not quite sure what you caught me there. What are you referring to?
Oh, like actually obtaining the data, I would say. Like how, yeah.
Or integrated meshes.
Yeah, because usually you would get that from third-party vendors, right?
Yes. Well, of course, now with Arcgis the Sure software to create integrated meshes being part of Arcgis is of course very helpful, because now you can actually use the Sure software to create integrated meshes, for example. We are working on new capabilities for integrated mesh creation, especially because what happens, of course, and all of you may be able to relate to that, is you get an integrated mesh and it's not quite right. The max screen threshold is not calculated correctly. The textures are too large. There could be some problems with it. And we want to have tooling available for users to fix this kind of problems. But that means that we really have to recache the data. So we really have to touch them. And that, of course, is not easy to do. And also, not everybody is a big fan of when you change their data, for example. One question that I see here in addition is, what about voxelayers? Yes, the scene layers team is the one that takes care of voxelayers. I hope you all had a chance to see the presentation that Charlie gave for voxelayers for the Arcgis Pro SDK. but maybe Richard, who takes care of our I3S spec, can say something more about the Voxelaire I3S spec that's to come.
Yeah, so for Voxelaire, we hope to project 1.9 release. And we hope that that will be by the end of the year, I believe, with the Arcgis Pro 2.9 release. But, you know, dates are still contingent on other things. But we hope that, you know, we can send these voxel layers as scene layer packages for, you know, better sharing and seeing some cool data sets.
Yes. A timeline would be hopefully with the next 2.9 release cycle that we can create the SLPKs for it. And the same way as you work with other scene layers, that you can then publish them to Arcgis Online and to Enterprise to visualize a voxel layer. What might have not been mentioned yet is voxel layers was in the beginning just an advanced licensing model, but now it's also available with basic. I have here one more question. How do point clouds in I3S compare to point clouds in Entwine? I don't have exact numbers of how much, you know, what the difference is. I've never benchmarked any of this. But we are currently working on improvements to the I3S caching mechanism, especially because we want to be able to handle larger point clouds and also point clouds with different density. We have seen that there were a couple of problems in the past, and we are trying to address them in 2.9.
Another question that I see is, I missed the definition for basis. What is that? So basis is a texture format, which is written by, I believe it's Google and Binomial. It's a highly compressible texture format and highly transcoded. So that basis format can be easily transcoded to whatever platform your client is on. So if you're on a mobile platform or desktop platform, the GPU for those platforms take different encodings. And so the basis format can transcode to those encodings relatively quickly as compared to just a JPEG or PNG texture.
And this we have benchmarked, and I think we had it 2 times, 3 times faster than the original JPEG. I believe that was that's of course always depending on the data itself that you're looking at.
Yeah,
the
compression is also about 3 times better than like JPEG. So really good stuff.
And the first way to make this accessible is most likely via the converter that Richard has presented, so that you can take an existing integrated mesh SLPK or 3D object scene layer SLPK, and you can convert it into 1.8, including that you want to convert it to basis. The first client, as Richard has already mentioned, will be the scene viewer to actually take advantage of this. I'm just quickly looking into the poll that we did, and one thing that is very big here is really on the content management side with integrated meshes, clouds. I assume these are point clouds, 3D building layers, and Entwine point tiles. So my impression I'm getting here is that we are looking into really the data management side that people are mostly interested in on creating, and not so much on the client consumption side, for example, to write their own application to consume I3S, for example.
It looks like on this poll, a lot of this is open source creation tools, VR, I'm assuming virtual reality. manage complex scenes, polygons, read and write. Yeah, so we hope to get reading of I3S in as one of the next features from Esri. So hopefully we can get that in rather soon.
I think the cat woke up, Richard.
She did. Letting me know she's awake.
So we will be available still for a little while. So if you have additional questions, please let us know. Also, if you have some just general topics that you would like to get more information on, we are more than happy to help on that as well. Maybe one thing I would like to keep or post, because I'm not sure how this will be accessible. How can I? Maybe it's just add information.
We got one more question here, actually, Yvonne.
Okay.
Will Esri support automated texturing workflows for 3D objects? I'm not sure. That seems a little bit vague, but I'm not sure if you could speak more to that.
If you mean procedural runtime textures, then one way that we want to support automatic texturing or even creating really large content is via 3D object feature layer. I don't know if there was a presentation on that on the Pro SDK island. But what you can do right now in 2.8, in Arcgis Pro 2.8, is you can create a 3D object feature layer that can, for example, be instanced from a GLTF or OBJ input. And then from there, you can create a scene layer and then share it across the platform. This is the first step that we are doing in that direction. So the sharing of this 3D object feature layer as a 3D object scene layer by caching on the server will be coming in 10.9.1 2.9, Arcgis Pro 2.9 and Enterprise 10.9.1 timeframe. That's what we are currently planning. Richard, can you see how we can actually give information here in addition? Because I would like to at least have the links to the GitHub spec and the Esri i3s lib out there for users to see.
Give me 1 second here. Let me check it out. I believe they can download the PowerPoint. Let me check where. It looks like there's another question, Yvonne, if you want to go ahead and read that.
So rather than modeling large, broad geographies, we hope to use your new capabilities to model much more focused models of detailed industrial sites with high local complexity. We would lean to 3D objects capabilities. I'm not quite sure if this is for buildings only. But what we have currently available is you can bring in Arcgis Pro 2.8 Revit models as well as IFC models, and you can create an SLPK from it and publish it, or you can also create a scene layer with associated feature layer, as I have mentioned in the presentation. And with this, you can bring in, if the moment that you have all this data in your geodatabase as a building layer, you can share this as a building scene layer with associated feature layers, and this is editable. What that means is you can start adding more of this complex buildings to one building scene layer. And you can basically build an entire campus using this mechanism. We have one example that I'm not quite sure if it's publicly shared, of the University of Ohio. OSU, I'm sorry, I'm not American, I don't know better. It's OSU, and there are about 90 buildings of the entire campus in a building scene layer.
Yeah, and I actually can see right here. So on the presentation that our users see, if you scroll down on the left-hand side, there's a gray box where it has information about the session. At the very bottom, it says supplemental files, where there's a PDF there for the presentation that we gave. And that actually will have the links to the GitHub repositories for the i3s spec and the i3s lib. And you can kind of review any information in case maybe we were going too fast in the presentation earlier, or maybe you want to review it again.
Does the building scene layer has performance advantages in comparison to the default multi-patch layer, and what are the differences? The building scene layer is designed to really show the entire building, meaning from the smallest light switch to an entire AC unit, for example. These differences in size, we are actually taking care of that in the different LODs, for example. It is much faster to turn off category layers. So a building scene layer is organized in disciplines like architectural, structural, piping, for example, and within these disciplines, you have your category layers. We have optimized this for drawing performance in all the Arcgis clients. What we have also done in addition is we make it easy to filter across this building scene layer quickly, so that you don't have to create really large and complex definition queries to query all the data across all the category layers participating, or you have to manage this. You can actually just create the search itself in the building filter, and you will then only see the objects that you are interested in.
So there's a question here that asks, could you explain the difference between editing attributes only and editing geometries in terms of recooking the cache? If you're talking about enterprise, when you're updating your scene layer, when you recache attributes, it should be a lot faster. We only update the features which attributes have changed. Or if you're editing geometries, I'm sorry, both should be faster. If you're editing geometries, it should be the same case. It should only update the features which geometries were edited. So we have a partial update feature on Enterprise where it only updates things that are different on the server versus locally, or what you have changed on the scene service. That's in comparison to full cache re-update, which recooks the whole layer.
If you are on your enterprise system, of course, a partial update makes sense if you have medium-sized changes. Let's say you changed 50 features and you just want to have a really quick recook. You should do that. You can do multiple partial updates. What happens on the technical side is that we are introducing new tree nodes for these partial updates. That means that over time, your tree, your node tree could actually be unbalanced. And that's why we are recommending after a while to do a full update again. For attributes, if you really just change attributes, like for example, in the building scene layer, that's very often that people just change specific attributes of their assets. There, it is then best to really only do the attribute updates, because there the attributes are changed in place, so within the existing node structure. So there is no unbalancing of the tree.
And there's actually a setting on Enterprise where it's partial update and then partial update attributes only. So the attribute only is what you would need to pass as a API call to the Enterprise server to update in place instead of adding nodes to the root node of the tree.
The intent of the voxel layer that can be shared as a scene layer. We are planning to have the same kind of capabilities that we currently have in Arcgis Pro, meaning you can create we just did the WebGL implementation. So we still have a longer way to go, but the plan is to have it in 2.9 10.9.1 timeframe. There's another question that just came in. What are your thoughts on 3D spatial operations on 3D objects, point clouds, 3D buffer, spatial SQL operations, such as contained by 3D interactive selections, query, all the good stuff I see. What we have focused on in the last release cycles is tooling to make data management easier. For example, we included the project tool. We included the clipping tool that comes with Pro 2.8. There is a tool to clip out LAS files from a point cloud scene layer, for example. What you are mentioning here are 3D geometry operations. And I know that people on our team, Yevgeny, Vladimir, they have looked into it and what we want to do in addition. And we make that part of the 3D geometry operations that we want to work on as well. But my thoughts are that for users, there shouldn't be a difference between working on a scene layer or working on a feature layer, for example. One thing to mention is if you have a scene layer with associated feature layer, let's say a 3D object scene layer, and you are using it in geoprocessing tools, that is possible if the tool is supporting, for example, multi-patches as input type. So let's take, for example, the tool multi-patch to footprint. I think that's how it's called. Then you can use, for example, a scene layer for that as well, as long as it has this associated feature layer and basically the two building this unit that then can be used in your GIS system. Yeah, for us, it's a little, or at least for me, the last, well, not the last one, but the one before the Dev Summit was in person. And of course, the interaction is much easier because we would, of course, like to, make sure that you get all the information that you need. It also would be possible to go to the talk to the experts island. I think it's on the main page, talk to experts. There you can still find more information about i3s and the different scene layer types for anything that we were not able to answer, or for questions that you haven't really gotten up with yet. In one, I think it's more like a comment. In one slide, you show the following types: 3D objects, integrated mesh, point cloud buildings. The multi-patch fits into this. If you have a multi-patch feature class, you can publish this to a scene layer to take advantage of the fast performance with the LOD creation by creating from this multi-patch feature layer a 3D object scene layer. Depending on how you share it, if you, for example, cache it on the client, you are disconnecting it from the multi-patch feature layer. So for example, you are just creating a package and you can share that in a mobile scene package, for example, and use it on a mobile device, or you publish it to Arcgis Online and make it accessible to everybody to just view, because you don't want to give this data away for other people to edit, for example. You can create a scene layer package and work with it. What you can also do is you can create a scene layer with associated feature layer. And at that point, the connection between the scene layer and the feature layer remains. You see this, for example, when you publish a multi-patch feature class. Let's say you have all your buildings in a multi-patch feature layer, and you publish this to your enterprise or Arcgis Online. You get two items. You get a scene layer item and you get a feature layer item, what is the multi-patch feature service. They are building a unit. They are related to each other. So this is also the mechanism on how the editing and the updating of the cache, the scene layer cache, actually works. You can make all your edits in the feature service by accessing the scene layer, for example, or accessing the feature service directly. And then you can make this update, so you keep your data up to date for your audience. One of the advantages to use a scene layer is performance. So if you really are looking at millions of buildings, it will be much faster to visualize this with a scene layer, drawing the feature layer in itself. That's for Arcgis Pro. In the scene viewer, for example, you can only consume a scene layer. I hope that answered the question. I understand that this is a very difficult concept, that we have the scene layer with associated feature layer. But because they can actually build this unit or be handled independently, for example, in a scene layer package, we wanted to keep this this flexibility for our users, really depending on how they want to use it. Maybe one more thing to the editing workflow in general. So as I said, it really doesn't matter much if you have a scene layer. Editing works the same way in Arcgis Pro as it does for a multi-patch feature class. So you can do exactly the same things. You can also, if you have a scene layer with associated feature layer, you can open the attribute table. Again, because they built a unit, the multi-patch feature service that was created and the scene layer, you can have this information coming from the feature service. I wished I could also ask some additional question, but I think I can only do that in a live poll. Maybe I can just create one, and that would be, how many of you have used scene layers already? Oh, this is a multiple choice. Open text. A little late. We just have 2 minutes left. I'm sorry. I should have thought about that in the beginning.
Yeah, a good final question before the session's over.
A good final question before it's we will have to the next time. Let's hope the next time we can all see each other in person. But if we do it online again, we will think about all the questions we have up front. I want to say thank you so much for your interest in scene layers. As I said, please reach out to the experts, and we would love to hear from you again.
Yeah, I'd like to thank everybody so much for your time and appreciate you listening to us and asking so many questions.